Very often, structural engineering firms face challenges in hiring local top talent. Often, highly skilled candidates are looking to work remotely, and there are more globally distributed projects. Efficient collaboration, communication, and seamless data exchange between teams are critical. It is also common for structural engineers to enter the same data into several different software applications multiple times for different purposes. With each iteration, several different models are produced, making it hard to collaborate between structural designers and engineers. This poor collaboration process is prone to errors and impacts the quality of the project. A solution for all these challenges can be work sharing and using the extended BIM workflows across the design process. Rather than working in siloed systems, structural designers and engineers can use the BIM 360 environment. BIM 360 Docs integrates the entire project workflow from design to construction across one common data platform. The extended team of structural engineers can easily review what has been done in Revit and stay up to date on the current structural project. When project teams have the right information at the right time, work happens faster. BIM 360 Docs lets them publish, manage, review, and approve all drawings, documents, and models, anytime, anywhere. The project teams can not only review all information, but they can also download project files. Having access to the project data, a structural engineer continues the design process, performing structural analysis and running code checking optimization. The Revit analytical model can be sent to Robot Structural Analysis Professional with all the information needed for structural analysis, including boundary conditions and loads. Interoperability with Revit, combined with powerful analysis and code checking engines, gives engineers the best tools and fastest path to train up staff. Thanks to many ways of presenting results of the analysis and the ease of accessing them, structural engineers can very quickly prepare the final documentation for review and input by project stakeholders. Results can be presented in the form of colorful maps of displacements, moments, stresses, etc., obtained during structure analysis to provide a visual snapshot of how the structure behaves. All of these make the software very intuitive and easy to use. Once designs change and analysis has been completed by the engineer, the information can be brought back into BIM 360 Docs to allow the designer to review the design changes and update the physical model accordingly. Here, structural engineers can upload their structural analysis and code checking documentation in the PDF file format. Also, analysis results can be easily stored and explored in the Revit environment, so Revit users could gain knowledge on structures' behavior, have insight in consolidated detailed results, take appropriate design decisions as well, and even properly document these. Once the Revit model has been updated after the analysis and code checking process, the structural engineer can upload a new version of the Revit project to BIM 360 Docs. Then the structural designer has access to the updated, optimized model by the structural engineer via BIM 360 Docs. Using the Compare tool, the structural designer can get insight into what has been changed in the model. BIM 360 has integrated change visualization that lets users compare the changes between two selected versions of the project. This summary provides a quick accounting of changes made by the structural engineer during the code checking process. Thanks to BIM 360, structural engineering companies can employ the best and the brightest engineers by adopting a BIM process that allows them to work anywhere, better collaborate, and spend more time problem solving.